What's this experiment today is all about? The experiment today is all about using Beer's law, correct? Beer's law to determine the concentration of a solution, correct? And especially in forensics, correct? You want to try to see what type of or how much the concentration that might have caused somebody to be killed, you know. Those type of techniques are used really in the real life. One of them is this Beer's law to determine the concentration of unknown, correct? So you know that the person died by poisoning, but you don't know the concentration of this poison. So you can run this experiment to learn about this. So when I saw the experiment here right up, they don't show you all the details. So all this is my addition to the lab, so you can understand. The Beer's law is saying to us, what it says, that the concentration of a solution is direct proportional to its absorbance. What do we mean absorbance? Taking the light in. So you can see here from the picture, the light going in, maybe I will have this one here. Just hold on here. The light going in, so intense, correct? This is light intensity 0, and this is the light intensity final, initial and final. This is after being absorbed by the solution. So after it's absorbed by solution, the color of the solution of the light intensity will be less, will be not the same, because part of the light is absorbed by the solution. Now, this type of absorption is direct proportional to what? The concentration. This is very important. That's what it says. The absorbance of a solution, absorbance of the light by a solution is direct proportional to its what? Concentration. From this, I can determine the unknown concentration. So I can tell, okay, to the judge, if I'm a chemist subpoenaed by a judge, well, this is from forensics lab, came out to be, this is the concentration that had caused the person to die. And most probably the dosage is very high, highly concentrated one. So that's what it says. The light will be absorbed by a solution is direct to its what? Concentration. And if I go further here, that was not in your original stuff here. So I went here and then showed you here. That's the old spec. So I will add the new picture. I took the picture of this. I will add, you will see this one will change. I will add another picture of the new. That's an old one. Without using a computer. With using the computer, then you will get something looking like. So here it is. Let me take the other one. One page. Okay, let's look at this one here, guys. And I have to increase the. I give you a sample here from the manufacturer of the company. So here's the concentration. As you can see here, this is the concentration, correct? And the concentration is going what? Down by increase. This is an increase, correct? This is an increase. Increase. So you can see the same trend has to show the absorbance. So the concentration is increasing more per liter. So the absorbance, so do the absorbance. So both of them are direct proportional. So you can see. At the end of the experiment, you check your unknown, but nothing is inside the spec, and then you can see your unknown will be somewhere here. This is your unknown, and then you can read it. It is 0.282 mole per liter. So is this technique is used in forensics and in medicine? Yes, it really does. So okay, so you can see this is your unknown, and that's what we have to do today. That's what we have to do today. So let's go back and look at the how we approach this one here. Well, very simple. I did for you all the calculation you need, everything you need. So here it is. You will have, each group will have different. So some group will have a green nickel, that's a nickel nitrate hexahydrate, nickel nitrate hexahydrate, correct? And some of you will get cobalt chloride or nitrate hexahydrate. So either or. So you get, some group will get the nickel, some will get the cobalt. So the cobalt is the pink color, the rosy color, and the nickel is the green one. Nickel is what? Most of the source of the is green one. That's not the case. What color is that? What color is that? Yeah. Right? That's right. Yeah, that's correct then. That's correct. Okay, guys. So after that, you will have to calculate the molar mass. You have to calculate the molar mass of what? You have to calculate the molar mass of your salt here, of this nickel nitrate hexahydrate or cobalt chloride hexahydrate. I get for you the molar mass, and you have to prepare 0.4 molar solution. This solution here has to be prepared. Okay, guys. So how to prepare 0.4 molar solution of your crystals here. You have some of you will get the green, that's nickel. Some of you will get what? The red one, the purple one or the red one. So how to prepare this? I showed you the calculations here. You start with 0.4 mole per liter. You have to prepare, you take out of this 10 mL of the solution, correct? 10 mL of the solution. Then you multiply it by the molar mass of this crystals you have. You will get what? You will get your number of grams. Those number of grams, take them, dissolve them in 100. This is 0.10 liter. That's 100 ml, not 10 ml. That's 100 ml of the solution. So you take, if you have nickel, if you have, guys, show some respect, please. You are not in high school here or kindergarten. You have to always show respect. If you don't show respect, then education is not good. Even if you are in the company or something, you have to show respect for your manager, your co-workers and everything. You start acting up, guess what? Manager will tell you, don't come tomorrow. You're fired. But I can't tell you you're fired. That will affect your final grades. All this behavior through my 30 years teaching here from Kansas State and then Colorado and here. People was acting up at the end, the finals become very bad because they don't listen. What's going on? There will be a quiz. Will be posted by tomorrow about this stuff. There will be final. The final is not mine. Same thing like the lecture. Lecture is not mine. So be prepared. So we have to respect ourselves a little bit. So how you prepare now? 0.4 molar per liter in 100 mLs of distilled H2O. So I showed you the calculation here. If you have the nickel one, the green one, you have to weigh 7.3 grams. You have to weigh what? Here it is. Let me take this one out. If you have the nickel one, if you have the nickel, which is the green one, then you have to weigh this one here in 100 mLs. So this one dissolved in 100 mLs, correct? In 100 mL. If you have the purple one or the rosy one or the pinky one, this is the cobalt here, you will weigh 5.2 grams in 100 mLs. Are you following me here? So now you have, this is yours. So those solutions called what? Our stock solution. Our stock solution. What means stock? Stock is, we keep it in stock for a long time, and this is the most concentrated solution. The most concentrated solution is the stock solution. So the most concentrated solution is our stock solution. So our stock solution is 0.4 molar of nickel, or depending what you have, or cobalt. So you have cobalt or nickel. So that's our stock solution. When you are done with this preparation, go here, you will need take the whatever grams you have, like 7.3 gram of nickel in 200 ml of volumetric flask. You fill them in, and then you mix them very well, and you shake them very well, because crystals, you have to make sure every crystal is dissolved. Then you have your stock solution inside what? Inside your volumetric flask, the 100 ml of your volumetric flask. So now you prepare 4 test tubes. Just here, this is a picture show you here. So that the more red the solution is, the more pinky is the solution. If you have a pink solution, the more concentrated the solution is. The painted pink here is concentrated. So you see the concentration goes up in direction of more red color, and the absorbance as well. So if you go like this way, the absorbance, the more red, the higher the absorption. The more red, the higher the absorption. The least red, or pink, then the least the concentration. So you set 4 test tubes in a rack. You have a plastic rack, I think. Put 4 test tubes. Then you will pipette. You can use graduate cylinder. Easier to use graduate cylinder. Prepare 4 solutions. You don't need to do, this is just a demo here, how the colors looks like with the concentration. You will do 4 solutions. So first, so how many solutions we have? We have 5. One is the stock solution, which is coming here from here. That will be in your volumetric flask. Correct, guys? That's your stock solution. If you have the red or the pinky one, that's cobalt. So you'll dissolve 5.2 grams inside 100 ml volumetric flask. You add to them 100 ml of distilled H2O. You shake very well. This is your stock solution. The same thing you do if you have the green one, the nickel one. You take 7.3 in 100 grams. Correct, guys? So now, this is your number one solution. Then for that, you have to prepare another extra 4 ones. How many now? We have 5. 4, how will you prepare them? Well, you take from a volumetric flask, the first test tube here, you take 2 mL. Take your flask, the graduate cylinder, just measure 2 mL, and then in the test tube, and then add to this test tube another 8 mL. If you think the test tube will not carry the whole 10 mL because the total is 10 mL, so what you will do, you get yourself small tiny beakers here, and you can keep those mixtures in 4 beakers. Instead of test tubes, you can use them use beakers. Because I'm not sure if your test tube, do you have the test tube, the larger one? The small one will not hold the 10 mL, most probably not. So this is the first test tube, 2 mL of 0.4, then you will add to it 8 mL. So I did for you the dilution law here, and the concentration is here. The concentration is here, 0.8. So if you look at this, this is, let me just, so this is your, after the dilution, this is your concentration. Second test tube, we don't have the test tubes that can carry the total volume of 10, use small tiny beakers. Use what? Small tiny beakers, because I'm not sure what's you can check. If you have the larger test tubes, yes, they can carry 10 mL total. But if you don't have, then use small tiny beakers for the 10 mL. So you take the second solution, 4 mL of your stock solution, correct? Then you add to it 6 mL of distilled H2O. Make your dilution calculation. This is the concentration of it, correct? And this is the third. From the stock solution, you add distilled H2O to it. This is your third concentration. This is your stock solution volume. You add to it this. And from what you see, what's happening here? Is the concentration increasing or decreasing, going down? What's happening here after you are making the dilution? It's increasing or decreasing? It's increasing. You start with 2 mL, 8 mL of H2O, so it means this is very dilute. So it's increasing. You go down and it is increasing. So it is what? Increase. So we have an increase going down. We have an increase going down. So now, time to use what? Your spec 20. I have for you the old one. I apologize. I thought they used the old one, but now they use a very fancy one. So I will add, this is an old one. The new one, I will add it for you in a couple minutes after I am done. I have the picture of it. So here it is, guys. This is the old one, but yours is the new one. That's in front of you, the small tiny box called spec. Not spec 20, but visual, I think visual spec. So what will happen when you log into this? You don't open any experiment, just open the logger pro. Your left, there is in the icons, there is logger pro. When you open it, you will see something like this, correct? Make sure that your spectrophotometer is connected and it's warmed up enough, more than 15 minutes at least. Now we are talking more than 15 minutes, should be there. So you will see this one here. So you will come here and prepare your solution. You have 4 beakers, correct? Those 4 beakers are here. And the 5th inside the volumetric flask. The 5th where? In the volumetric flask. So you take the first one. This is the first solution here, second, third, fourth. So all those 4 solution, 4 beakers. And then from those 4 beakers, you wanna, this is your cuvette. See here? This is your cuvette. So this is very unique cuvette here. You will see in some areas, you look like this. This is the light will go through. The most non-smooth area, dull area here, this is very opaque. So it reflects the lights out. So we have to fill it with the solution number 1. Everyone is following here? Solution number 1 is from the table there, you have 4 solutions, correct? Take solution number 1, you rinse it. You have to have a waste container today near you. A beaker called waste. Because at the end of the experiment, we should put everything inside it. Those 2 chemicals you have, they kill the kidneys and the liver. So we don't want to put them inside the sink. They go and end up, if they are not trapped inside a trap, they skip the trap. We have a trap. Every chemical lab has a trap, the sewer. But if they skip, they go to the fish, the rivers and the ponds. So it's happened, then they kill the fish. So, and make sure that you clean up your hands today very, very well. You don't get anything, traces in your finger, and then you start eating stuff. This stuff. Cobalt and nickel are heavy metals. They can cause damage for the kidneys and the liver. So make sure that you understand this and you are aware of this, and they are highly toxic. It's not really a joke. So nothing in inside the sink. After you dump the whole thing, traces of it, small tiny amount, you can rinse it with a lot of H2O, your tapeworm. So you will fill your sample here up to the 3/4. See the size here? I showed you the size. So always try to, here in the top, don't touch anything here. And the one is very nice. Put it in the light will go through like this. The light will go through, and because the solution has a color, it will absorb part of the light. The light will go in, that's the intensity, and will be recorded. Correct? The intensity here will be direct proportional related to the concentration of the solution. So you will record what? You will record the absorbance from the software. Are you following me here? Then if you are done, take it, rinse it. You don't have to take 4, the same one. Take the same one for all experiments. Take it, rinse it, put the whole thing in the waste beaker you have, then rinse it with this distilled, then put the second solution from the second beaker inside, up to here. Same side, the same distance here. So, and then you put inside, you will measure your solution, your absorbance, how much. You know the concentration of it, because the concentration is here. The concentration is already calculated for you. That's the concentration here. This one here, this one here, this one here. What's missing of you here today is to determine the concentration of the solutions you are using and the unknown. So you will do 4 times, but before doing like this, we have to know what is the maximum absorbance. See, that's you will do with the stock solution. What's the maximum absorbance of your pink solution or your green solution? Absorbance of the light. What is the wavelength? So you can put the wavelength there. So what you will fill here, this one here, how do you do fill the cuvette? The spelling of cuvette might be wrong, but it's TTE. It's CUVETTE, but it's okay. So here is the serious one here. So here you start doing the actual experiment by experimenting to know to calibrate the spec photometer. Spec photometer is sitting for almost more than 5-6 months. So you have to calibrate it using your own you roll it up, you'll use it, and then It's more than 15 minutes there, so it should be okay. And then that's how you calibrate it. So you go to the experiment menu of the Logger Pro, click calibrate, spectrometer, wait to warm up, then click OK. Click finish calibration. Then the next one here, you have to, find the optimal wavelength by which the stock solution is being absorbed. So you do the same thing here. You take your cuvette. This time you will not use the beaker. The beakers will come later on, but this is before the beaker. You rinse your solution from the flask, the 100, remember the 100 milliliter flask? You add to it, rinse it inside your waste beaker, and then fill it to the whole thing and measure which maximum wavelength it will give you. So here it is. So remove the blank, correct? Fill the cuvette. Remember when you calibrate, correct? Your blank will be H2O. That's what you prepare a position, a blank cuvette. So that's the first thing here you do here, your H2O because H2O what? H2O will allow the light go in, go out. Does not absorb light. Why? Is color, H2O has a color? No. The only problem if your solution has color, then yes, it will interfere with the light and absorb part of the light. But H2O means you should read 100% transmittance, zero absorbance, no absorbance, zero. Right? You should read zero absorbance. So that's when you use this one here. So don't jump any of these steps, one step at a time. So 4, 5, 6, you determine the optimal wavelength. 7, you start collecting, correct? Start collecting this, and you'll have your piece of paper, scratch paper, just in case the computer will shut down on you or whatever, data is not safe. Always a backup plan by your hand. So solution number, the stock solution, maximum wavelength like this. The solution in the beaker number 1, solution number 1 in the beaker, the absorbance is this. Solution, so get yourself a scratch paper or a paper, or write all those stuff in a piece of paper. So just in case something will happen to the software while you are doing the experiment. Correct? So, and then when you are done with everything, you get your cuvette. You will add up to the same size, 3/4 of it, your unknown. You get the code of your unknown, and then put inside the spectrometer and collect, press collect, and then see what is the absorbance. So now from this, you can make an Excel. And this Excel here, I did for you here, if you look, let me just, Excel will be looking like this. You see here the absorbance you have, absorbance has to go through 0. 0 absorbance, 0 concentration. And it goes 4, and you have 5, the stock solution is 5. So 0, 1, 2, 3, 4, and then the number 5 is 0.4. So you have all this concentration here. See here, 0.08, 0.16, 0.24, 0.34, 0.4. So please do not come with the same value. I'll be suspicious. This value is here from the manufacturer. I took it from where? Not mine, from the manufacturer. This is the same box you have here, the spectrophotometer. Give you this concentrations, which resembles our concentration, correct? So we will do all those 5. And then when we do all those 5, this is their their Excel. They did not use Excel. They use what? They use the software itself. Now, if the software will give you the curve, if it will give you a curve, so tell me, I will get you this snipping tool. You can snip it and then email it to yourself. You don't have to do Excel. If it's not, then you can do just Excel, X and Y, and then absorbance in your Y-axis and concentration in your X-axis. Those are 5, correct? And don't forget the 0, 0. So there is a 6 is 0, 0. So from 0, 0, 0.8.16, those are the concentration, those are your X-axis. And the absorbance, whatever absorbance you are measuring, put it in the absorbance, and you should be able to get this type of curve. So very ideal curve. You should get something looking like this. And then when you put the last thing, your unknown, you'll not do nothing. Just put your unknown inside, measure it. Your unknown is coming here, correct? So then your unknown, you can see, tell you what the absorbance is. From your absorbance, you can determine the concentration. Now, the Excel will give you Y equal A X plus C. So the concentration of your unknown will be your coming from the absorbed A. A is will be the slope, right? That will be your slope. But either or, you can determine the reading of your concentration of your unknown. So any question? Let's start, guys. Let's start doing. First of all, you'll start to do the stock solution. First of all, your stock solution, correct? And stock solution here. Okay, guys. Stock solution start is here, guys. Here, how to start your stock solution. Here, how to prepare your stock solution. If you have a nickel, that's the green one, or you have the pink one, which is the cobalt one. That's the 0.4 molar. So you have to look at your volumetric flask, 100 ml volumetric flask. You have to look at your 100 volumetric flask, right? And that's all yours. And then if you have a question, come and ask me. May I have your attention, please? Attention. I need everyone with goggles, including myself. I will get my goggles now. The goggles are over there. Those are very highly toxic material. We don't want to get them inside our eyes. So we have to protect our eyes. We have to protect our eyes, guys. So I'll get mine here. Here. If you see a glass that's green, that's anti-iron. Iron two.
They know if he's actually colorblind.
Oh, they are beautiful. All those transition errors, yeah, very colorful. Very, very colorful. Yeah. Very, very colorful. You get connected. Should be able to get now. First, you go for the. Okay, guys, goggles, guys. Goggles. Goggles, guys. Um, we have gloves as well. Gloves. I get outside pockets here. Outside if you want. Everyone with goggles, including myself, everyone with goggles. And if you prefer to use with gloves, there is glove box over there. What's going on today? This is almost 1 hour. What's happened? What's that? Thursday? Okay, that's fine. Just sign. Everybody had signed? Everybody had signed? Everybody had signed? Everybody had signed? If you don't sign, then I will consider you are absent. Really, I'm sorry, but I said everybody has to sign, so I know who is here, who is not here. So please, yeah. Attendance sheet is here. Attendance sheet is here, guys. If you don't sign, I'll give you 0 because I don't know that you are here. So you have to sign. So when I go home, then I say oh, all the students are there. So small beakers. You can use small beakers. Yeah. Well, with the class, you might have to look around. Open here, inside. You have to look. Yeah, they are inside the. The ones are here 200. Those too big. Ones are here 200. So. I really need nobody else to find yourself.